And you have to solve this equation?
Yes, ma'am.
Okay, so when you're solving an equation, the easiest way to do it is to get all of the x's on this side, the right-hand side, or excuse me, the left-hand side, and the numbers over here on the right-hand side. So see how there's a 5x on this side of the equals? Since it's a positive 5x, if I subtract 5x, and I have to do the same thing on this side, and I like to write it right underneath the other x term so I can kind of see what I'm going to combine up together. 7x and minus 5x, that makes 2x. There's still this minus 5. There's the equal sign. And look here, this is good news. 5x minus 5x, that makes 0. So I don't even have to write it, but there is still a 1. Now it's an easier equation to solve. I'm going to do this. I want to get this over to this side. See that minus 5?
Yes.
The way to cancel that out, plus 5. See how these had opposite signs? These have to have opposite signs too.
Okay.
There's 2x. Those are gone. There's my equal sign. 1. And when you get down to the final step, whatever number is multiplied by x, that's the one you divide by. Divide by 2, divide by 2. And here's my answer. X equals 1 divided by 2. You can leave it like a fraction, or if you grab your calculator and go 1 divided by 2, it's 0.5. So if this is a geometry problem, then do you have to go and put that 0.5 in for x somewhere in a figure, or is it just solving this equation?
It was solving the equation, but it gave me the steps.
That just takes practice. Solving those equations, the more you do it, the better you'll get at it.
Okay.
Is there another one?
Yes.
We can go over some more if you want.
Can we go over properties of tangent?
Of what? I didn't hear you.
Can we go over the properties of tangents?
Tangent? Okay.
Yeah.
So when you've got a right triangle, let me see. If you have a right triangle, there's 2 acute angles. So I'm just going to pick one of them. If I pick this angle right here to talk about, there's always, it has to be a right triangle, but there's always some ratios that will be the same if you know this angle. There's tangent, there's sine, and there's cosine. And when you look at these, like I'm gonna put some numbers here. Let's make this 3, 4, and 5. If I'm talking about this angle right here that I marked on, the tangent is always the opposite side over the adjacent side. Opposite is the one that's straight across. Adjacent is the one that's touching it. And the hypotenuse is always the diagonal side, the one that's across from the 90-degree angle. So tangent is always the opposite side over the adjacent side. If you're talking about the sine of this angle, It's really S-I-N-E, but they abbreviate it. It looks like sin, but it's pronounced sine. The sine of the angle is always the opposite side over the hypotenuse. Oops, sorry, I bumped my camera. And cosine, I'm going to move this down a little lower. Cosine is always the adjacent side over the hypotenuse. So in this triangle that I drew, if I call this, I'll just call it angle A to give it a name. For angle A, the tangent is the opposite side, 4, over the adjacent side, 3. It'd be 4 over 3. The sine for angle A is the opposite side over the hypotenuse. So it's 4 over 5. The cosine for angle A is the adjacent side over the hypotenuse. So it's the one touching angle A over the hypotenuse, 3 over 5. Okay, that works every time, no matter how your triangle is flipped or turned. You might have your right triangle turned this way, it doesn't matter. If this is the angle I'm talking about, and here's some sides, I don't know, I'm just gonna make up numbers again. Let's say this is 12 and this is 10, and this, I don't know what this is. I could figure it out though, because let me see. I gotta grab a calculator though. This would be about 15.6. So if I'm looking at angle A and I want to know what the tangent of angle A is, tangent is opposite over hypotenuse, or excuse me, adjacent. Opposite is 12, adjacent is 10, so the tangent is 12 over 10. If I wanted to know what the sine of angle A is, sine is opposite over hypotenuse, so 12 over 15.6. If I wanted to know the cosine of angle A, it's adjacent over hypotenuse, so the one touching angle A, 10 over 15.6. Does that help explain that a little bit?
Yes.
Hi, Celeste. We're talking a little bit about geometry here, but we can do anything you have if you have questions. So Celeste or Juana or Angela again, if you have another question, just ask. I'll try and help you out.
I do.
You're welcome.
I'm having trouble with special triangle, right triangles.
With the right triangles?
Yes.
So when you have a right triangle, there's a couple special ones. There's a 30, 60, 90 triangle. There's the 90. The 30 is always the skinny angle, and the 60 is the fatter angle. And when you have a 30, 60, 90 triangle, the side lengths are always in a ratio. And let me see if I can remember it. Let's see. This is x, and this is 2x, and this is the square root of 3 times x. I think that's the way they show it. So they're always in this kind of ratio. If, for example, if you have the 30, 60, 90 triangle, and you know that this one, here's the 30, here's the 60-degree angle, there's the 90-degree angle. If this bottom side right here is 5, then the hypotenuse is always going to be twice that. Whatever the bottom is, the long side is always going to be twice that. So it'll be 2 times 5, or 10. And this side right here will always be the square root of 3 times the bottom. So it's the square root of 3 times 5. And if you needed a number for that, you'd grab your calculator and you'd go, is that showing? The square root of 3, it's that funky decimal, times 5. It's about 8.7 if I round off. Okay, so one special triangle is the 30, 60, 90 triangle. The other special triangle, and these are just special because they're so common, people have just memorized these ratios, is a isosceles right triangle. If these are the same, there's the 90-degree angle, then these have to be the same also. These are both 45. So the angles are both 45. If this is x and this is x, this will be the square root of 2 times x. So here's an example, and look, I'm going to get tricky and turn it different. That doesn't matter. Here's my 90-degree triangle. If it's an isosceles triangle, means 2 sides are the same, then the 2 acute angles are 45-degree angles, even if I didn't draw it perfectly. If I know, for example, if I know this is 12, then I know this is 12. The 2 legs, they're called legs in a isosceles triangle. Oops. Did we freeze up? Can you hear me still?
Yes.
Yes, but you can't see my hand, can you? Is it moving? I think my internet maybe froze. I don't know what happened here. Oh, it's just slow. Okay, now it's back. Okay, so if the 2 legs, the 2 matching legs on this one are 12, then the hypotenuse is going to be the square root of 2 times whatever the leg is, times 12. So again, I'd go to my calculator and go the square root of 2. There's the square root of 2, 1.414, yada, 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 times 12. It's about 16.9, but the 9's going to bump up. It's about 17.0.
Okay.
Approximately. Okay, so this is the rule for the other special triangle. An isosceles right triangle is 45, 45, 90 triangle. The 2 legs match, and the hypotenuse is the square root of 2 times whatever the leg is. And in the 30, 60, 90 triangle, the short leg is x, the hypotenuse is double that, 2 times x, and the longer leg is the square root of 3 times that. These are fun. They're my favorite ones, the right triangles. Okay. Is there a specific problem?
Yes, sorry. it wasn't I think that it was just like me understanding the like the formula on how to get the answer was my biggest issue.
It looks real confusing, so you don't even know what it means.
Yeah, and I figure like once I crack the code, I'm going to be really good at it.
Yeah, but it almost looks like a different language when you look at it all. I know.
Yes, it really is. It's been the most challenging class. There's a beauty to it. Does it matter the kind of calculator that we use? Does it matter? I know some.
No, it really doesn't. You can use, for these, you'll want one that has a square root key, but almost any does. In fact, I mean, I have this graphing calculator, but you can look like on my phone here. I think there's a calculator on my phone. Oh, there's my calendar. And if you go here, well, this one doesn't have, you need to find one that has a square root key. But I think you can find just a calculator that, I thought I had one on my phone one, but I guess I don't. You'll have to have one that has at least a square root key. And I think later too, have you done any of the circle units? You'll need one that has a pi key too. But most any calculator will have that. You can find one on your phone that's free.
Are we allowed to use the notes on quizzes?
Yes, you are.
Okay.
Hi, Yadira.
Hi, I'm sorry. I got the wrong time in the email.
Oh, that's okay. We're just answering questions. If you have some questions.
In the email, they say at 6 o'clock, and I was waiting for the, Okay, sorry.
Are you, this is 6 o'clock on the East Coast, 3 o'clock on the Pacific Coast.
Oh, this is a 6:15 right now in Eastern
In the
Ohio.
East?
Yeah. Where are you located?
Yeah, I'm in Washington State, and it's 3:15 here.
Oh, well, okay. Yes, I want a little bit of everything. Not your
Well, if you have some questions, I'd be happy to help. People are just coming up with questions that they have, so whatever you need, if I can help, I'll be happy to.
What do you have right in front of me? I see you got
right here. This is some geometry. Some of the students were asking about the special triangles in geometry. But if you have algebra questions, we can look at those, or whatever math class you're in, I can help you. I hope. I'll try anyway.
Yeah, I like your class. I was in your classes before. I love it. That you go through every point and explain slowly and everything. I like that.
Well, good. It's hard. Math is hard on the internet. You have to be slow and careful because nobody can ask questions. That's why it's nice to have a live session like this too, where you can ask a question.
Yeah, can you explain what you have right in your piece of paper in front of me? Did you have triangles and I see the...
These ones? Yeah, I just wrote these.
I see you had a square root over there, and so you're looking for areas or what?
On these, no, somebody asked about the rules for special triangles, for special right triangles. If you have a 30, 60, 90 triangle, the sides are always in this ratio, x, 2x, and the square root of 3 times x. So then this was the example. I said, well, if the bottom is 5, if the short leg is 5, then the hypotenuse is 2 times 5, 10. And the longer leg is the square root of 3 times 5, the square root of 3 times the bottom. And we used a calculator and got this 8.7.
Mm.
Okay, and here's the other special triangle, an isosceles right triangle. If the two legs are the same, they're both x, the hypotenuse is the square root of 2 times x. So on this example, if the two legs are 12, the hypotenuse, the long side, is the square root of 2 times 12, or approximately 17.0. And again, we used a calculator there to get that answer.
Oh, I see. I can do
So
it.
which class are you in?
Algebra?
Algebra? Do you have some questions there? Which lesson are you working on?
Scatter plot and correlation.
Oh, on the scatter plot, that one, I can give you a hint. I know, so you've been working with the Desmos calculator?
Not with the calculator, but yes.
So when you go to that
Oh, yes.
calculator,
Okay. The small
you
account, yes.
can,
For graph.
yes. So when you go to that calculator, if you get your scatter plots on the screen, there's a couple of things I know, just because the first time I did this, and I've watched students do it now since then. Sometimes you have to adjust the window that you're looking at. So up in the upper right-hand corner, there's settings.
Okay.
And you can change it so that if you like, if the window on your computer goes from, if it's like this, and it goes from 0 to 10 and 0 to 10 this way, but then the things that you're graphing are in the hundreds, they're way off the edge of the screen. So you have to change the settings so that it goes farther. That's one thing that will help.
Okay.
When you, to see your scatter plot. I know students have had that mistake. And then I also know on the assignment, when you put in the correlation coefficient, for some reason, it doesn't count it right unless you put 0. I think like one of the problems on the assignment, it asks you to find the correlation coefficient, and I've had students, do it, and they do it all right, and they find the R value, and it turns out, I can't remember what, something like 0.96, and they write 0.96, and they get it wrong. For some reason, the autocorrect needs to have a 0 in front. So be sure you put the 0 point, whatever it is.
Oh, I see.
Which it's very frustrating because 0.96 is the same as 0.96, but for some reason it doesn't like it unless the 0 is there, and it marks it wrong every time.
Yes, it happened to me, yes.
Yeah, so be sure you put in the 0, and that will help on that one. And we have another new person, Lakia. Hello, Lakia. If you want to unmute and ask a question, you can.
Hello. Can you hear me?
Yes, I can.
Okay. I was having issues with, I'm currently in Algebra 1. I'm having issues with variables, elimination, and relations, and a couple others.
Okay, so let's see. Elimination, so if you're solving systems of equations, and you're using elimination, let me see, I need my scratch paper here before I write one. I want one that will work. Okay, let me see here. This would be, Okay, I think I wrote a problem that'll work. So if I have this system of equations, 2x plus 5y equals 4, and this equation, 4x minus 2y equals, oh wait, I don't know if this is going to work. Let me change this to a 6. Equals, dang, I don't know if I'm going to get it to work at all. 9. I'm not sure. We'll see. Anyways, so to solve this by elimination, look at the x's.
Right.
These are the same number, but what if I took the whole top equation and multiplied it by -2? So then the top equation would become this, -2x plus -10y equals -12. Let me stop and let you look at that. You see what happened? I
Okay.
multiplied the whole top equation by -2.
I see. Okay.
Okay. And now, oh wait, gosh, that's a 4. There, now you can see what happened better. So I multiplied that by -2, multiplied that by -2, and multiplied that by -2. Now if I put the bottom equation right underneath it, 4x minus 2y equals 9. When I combine these together now, those are eliminated. Makes -12y equals -3. This is where I was trying to make one that worked out a nicer number, but it doesn't work out that great. Oh, it froze.
I'm sorry to interrupt you, but my computer froze.
Mine did too. Just a minute.
Oh, okay.
Let me see if I can get it to work.
Okay. Well, those are some cute dogs.
Yeah, those are my doggies. There they are. Dang. Okay, let's see. There we go. Is it back?
Yes, I see it now.
Okay, I'm sorry. I don't know what
It's okay.
happened. My iPad froze up while I was writing, and I don't know what
I
happened.
thought it was my
Okay.
computer.
No, it was mine. Okay, so I multiplied the whole top equation
Right.
by -2 and got this.
Right.
I put the bottom one right underneath, and those eliminated because they're opposites. When I add those up, I get -12. When I add those up, I get -3.
Okay.
And now I can get the answer for y. I just have to divide by -12. So y equals negative times negative makes positive, and 3 divided by 12, I go to my calculator, 1/4 or 0.25. I meant to make one that was a whole number, but I didn't make up a very good whole number answer. And
It's
once
okay.
you know this, you can get the answer for x, if you have the answer for y, by putting that in for x, either, or in for y, I mean, right here or right here, either one. So if I put that in right there, I like that one better because I can do it in my head.
Okay.
4x minus 2 times 0.25 equals 9. So 4x minus 0.5 equals 9. Now I'm going to solve this. Add 0.5, add 0.5. It's like adding 50 cents. I can do it in my head pretty much. This is 9.5. This I can't do in my head though. Divide by 4, divide by 4. I'm going to grab a calculator here. 9.5 divided by 4 is 2.375. Yuck, it wasn't a good number at all. So there's the two answers.
X. Okay. Wow.
Yeah, it's let me see if I can make it easier. What if I have, okay, I think this one will work. I don't know, we'll see. 3x plus 2y equals 7. And the second equation is 2x minus 1y equals 0. So there's two equations there. If I want to solve that by elimination, I have to find a way to make either the x's eliminate or the y's eliminate. Have any ideas?
No, I'm sorry.
No? Okay, so no, you don't have to be sorry. So here's what I do. If they both have numbers in front of them, like the x's do, I try and think in my head, is there a way I can make a 2 into a 3 with multiplying? Not real easily. Or a 3 into a 2, not real easily. But I could make them both into 6s. But I'm going to look over here at the y's. Look at the one on the bottom. It's got a -1. Can you make a -1 into a 2 by multiplying? Could multiply by 2, right?
Right.
If I take the whole bottom and multiply by 2, the y's will eliminate, because look what's going to happen. If I multiply the whole bottom by 2, 2 times 2x, that's 4x. 2 times minus 1y, that's minus 2y. And 2 times 0, that's 0.
Okay.
So I doubled the whole bottom. Look at, now the y's here. I'm jumping over that one in the middle. They're going to eliminate because this one's a plus 2y and this one's a minus 2y. So if I combine these up together now, 3x and 4x, 7x, 2y and minus 2y, those are eliminated. And 7 and 0, that's 7. So if 7x equals 7, divide by 7, divide by 7. 7 divided by 7 is 1. X equals 1. There's my answer for the x part of the equation. And the y part of the ordered pair, I just have to go back to one of the originals and substitute 1 in where the x is. So I'm going to put this right in there for x. And I'm going to rewrite it, but instead of that x, I'm going to substitute in a 1. 3 times 1 plus 2y equals 7. 3 times 1 is 3. Now I can solve this. Take away 3, take away 3. 2y equals 7 minus 3, 4. So if 2 times something is 4, just divide by 2 to get the answer. Y equals 2. Here's the other answer. So the point where there's those two lines cross is 1, 2. The solution to that system is 1, 2. X equals 1, y equals 2.
Okay. Thank you very much.
These are hard problems. You can see it takes a whole page of work.
It does. Yes, it does. I really appreciate your help, though.
No problem. No problem. Do you have a specific question on one?
No, because they're all hard. I think I kind of probably need to go through the beginning of them and follow each step. But I don't want to take up time from somebody else that might need your help as well. So I'll let you move on. But I really appreciate it. I'm gonna just continue to watch on the sideline.
Well, no problem. How about anybody else? Does somebody else have a question? Juana, do you have a question?
I have questions. I'm just not right now. I was
Okay.
scared.
Well, I'm happy to help anybody if you can think of something that you have a question about.
If nobody else does, I'm very awful in variables.
Okay, so give me an example because that's kind of a big topic.
Yes, it is. Actually, I kind of don't have any because when I got into this class, this is kind of new to me. I might have some notes. Let me look through that I didn't understand either. Now I do understand the no solution, all real solutions. I understand that. Let me see here. What about solving equations with variables?
So kind of what I was doing a little bit there, but when you have an equation, here's like the basics. If you have something like this, 4x equals 20, that really means 4 times x, times the variable x. So 4 times something equals 20. The way you get your answer is you kind of turn your brain around backwards and you think the opposite operation. The opposite of multiply by 4 would be divide by 4.
Oh,
so to
okay.
get the answer, you divide by 4.
Okay.
So x equals 20 divided by 4 is 5. If you've got a two-step equation, if you have something like this, like say you have 3n minus 8 equals 20. Ugh, it's not going to be a whole number again, but that's okay. So if I have this equation, again, I have to think opposite operations, but you start with this one. The opposite of minus 8 is plus 8. So you add 8 to both sides. I always draw that line.
Okay.
So 3n, because minus 8 and plus 8 are opposites, they make 0, equals 28. And now it's kind of like the one above there. Divide by 3, because that's the opposite of multiply by 3. And you get n equals, it's a bad one, 9 1/3, 9.33 repeating. I didn't make one that turned out a nice, perfect whole number, but it doesn't matter. Things don't always turn out nice, good numbers.
Right.
You can use a calculator too if you want.
Oh, thank God. Okay.
And then I can make ones that have something like this, like if I have x divided by 2 plus 1 equals -8. Same principle, though I'm going to do opposite operations to solve that. This says plus 1, so the opposite of that is subtract 1.
Right.
Mhm. So x over 2 equals, this is hard because I have negative numbers here, -8 minus 1. That goes farther into the negatives. It's -9. Confuses people because it kind of looks like adding.
Right.
But it's not really. It's -8 minus 1. It's just going farther negative. And again, you can use your calculator if you want. If you wanted to put that in your calculator, you'd put in -8 minus 1.
Okay.
And it'll give you
Okay.
-9. And now the opposite of divide by 2 is multiply by 2. So you multiply both sides by 2. The opposites cancel out again. That always happens. And this side is 18, and it's -18 because there's one negative sign there.
Right. Right.
Negatives always make it tougher.
Yeah, I agree. Okay. I think I
But
might have that.
the steps stay the same. You want to do opposite operations. And if you have variables on both sides, that gets even harder yet. If you have something like this, 4x plus 12 equals 6x minus 2. When you've got the x on both sides of the equation, you want to get all the x's on one side and all the numbers on the other side. And I'm just a creature of habit. I like my x's over here on the left and my numbers over here on the right. So I'd look at that 6x there and I'd think, okay, to make that over here, I have to do the opposite of what's right here. This is a plus 6x. So I'm going to subtract 6x, subtract 6x. Let me see, here's what I get. -2x plus 12 equals -2. Check that out. 4x minus 6x, that makes -2x.
Right.
That plus 12 is still there. The equals is right on the line. The plus 6x and the minus 6x make 0, they're gone.
Okay.
And that -2 is still there.
Okay.
Now it's pretty similar to the one I did before. I want to get rid of that 12, so I'm going to subtract 12. -2x equals -14. Check that out. There's the -2x.
Right.
The plus 12 and the minus 12 are gone because they make 0. That's good. That's what I wanted to happen. Over here, -2 minus 12, that's -14.
Right. Okay. I think I got that.
And now I'm to the last step. The opposite of multiply by -2 is divide by -2. When you divide, you keep the same sign.
Right.
Because -2 divided by -2 makes +1. That's good. 1x equals 14 divided by 2 is 7. And 2 negatives make it +7. You don't have to show the sign there.
Okay. Wow, this math stuff is something else. Okay, thank you for that as well. I appreciate it.
You're very welcome.
Trying to think of what time it is. I think I'm gonna leave the group now. I'm gonna try to take my final in algebra, but I just want to say thank you for all your help.
You're very welcome and good luck.
Thank you so much. You have a good day.
You're welcome. You too. Anybody else have a question? Anybody else? Questions? We can do some more math.
I would like to
Yippee
do-
skippy. I know you all love it. I think it's fun.
and I know you did this, and I would like to know if you could do the it was it was in the beginning. Let me find
With the special triangles again?
it. Yes, but it's not the right triangle. It is.
Oh, the trig stuff, the sine and cosine and tangent?
Yes. Yes.
So when you've got a right triangle, that little box is always in the right angle. The one that's across from it, it's always the diagonal side, the longest side of the triangle. That's called the hypotenuse. These two, the two that go together to meet to make the 90-degree angle, they're called the legs. And a lot of times, well, this is kind of before that trig stuff, but a lot of times they're called A and B, and the hypotenuse is called C. That goes right to the Pythagorean theorem. It says a leg squared plus a leg squared equals the hypotenuse squared.
Yes.
And that's kind of the beginning of all that trigonometry stuff. And after you do the Pythagorean theorem for a while, mathematicians started to notice that there were some patterns that worked every time when the angles were the same. So they noticed that there were similar triangles, and when you have a triangle that has a certain angle, like if this is 90, and if you were talking about this angle, if you have another triangle that's exactly the same as that, only like shrunken up. So if this is, like, I won't do a 30-60 one, but say this is 35 and this is 55, because they have to add up to 90. If I had this triangle, and if this one is 35 and this one is 55, they're going to be proportional. They're going to be the same, only one is just shrunk, or it might be bigger too, of the other triangle. And so they started looking at the ratios, and they noticed that there's always the same. If you know that angle, the ratios are always the same. So after doing the problems over and over again, somebody came up with what those ratios are, and those are called trig ratios. And they noticed if you've got a right triangle, and if I'm talking about this angle right here, and I don't know where these names came from, but they said, okay, well, let's see if we're talking about a specific angle right here, the opposite side over the hypotenuse, we'll call that the sine of that angle. I'm going to give it a name again. So the sine of angle A is the opposite side divided by the hypotenuse. And the cosine of angle A is the adjacent leg over the hypotenuse. Adjacent means touching. And the tangent of angle A is the opposite side over the adjacent side. So the opposite leg So if you know, for example, if I have some numbers here, if this is, I keep going to 3, 4, 5 because that's a pretty common one. I know that works out to be a true right triangle. But if those are the measurements of those, the two legs are 3 and 4 and the hypotenuse is 5, and if this is angle A, I can tell you what the tangent of angle A is. The tangent of angle A is the opposite leg over the adjacent leg. The one that's across from it, 4, over the one that's touching it, 3. I can tell you that the cosine of angle A is the adjacent leg over the hypotenuse. 3, the leg that's touching angle A over the hypotenuse, over 5. And I know the sine of angle A is opposite over hypotenuse. So the opposite leg, 4 over 5. What's kind of interesting, if I call this angle up here B, make this one. If this angle is B, I can find the tangent of B. Tangent is opposite over adjacent. Well, from angle B's perspective, the opposite leg is 3. The adjacent leg is 4. It's 3 over 4. Look, it's just upside down from that one.
This is my aha
The
moment.
cosine,
I'm excited.
yeah. The cosine of B, let's see, cosine is adjacent over hypotenuse. It's nice to have these notes down.
Nice.
Cosine is adjacent leg, so the leg that's touching B, 4
Over 5.
over hypotenuse, 5. Sine A and cosine B are the same. And the sine of B, sine of B is opposite over hypotenuse.
3 over
Opposite is 3, hypotenuse is
5.
5, 3 over 5.
Nice.
So what's kind of tricky on some of these, the triangles can be turned or rotated any way, and you can be talking about either angle. So you have to really pay attention to which angle you're talking about,
Yes.
and then know what these words mean.
Yes.
But if you can find the adjacent leg and the opposite leg and the hypotenuse, and you've got this down in your notes, finding those ratios isn't too hard. Hey, who else has a question? Angela, you doing okay?
Yes.
Okay, just holler if you have more questions. We got about 10 more minutes, so we can do a few more. Well, nobody else has questions? So we can look at some more geometry questions or some more algebra questions if you have any. Or
I know I have one. I'm gonna look for it. Sorry, I'm looking. I know I have a question. It was.
Is there a way we can go over the arc length as distance?
Sure. So arc length, if you're looking at like a circle, all the way around a circle, it's called the circumference, is
I can't
pi
see the
times
screen.
diameter. Can you see that?
No, it's something in the middle of your screen. It says move iPad.
Oh, dang it. I don't know what happened. Just a second here. Where is it? Yeah. I'm hitting every button I can find.
Hey, Karen, it's Cecilia.
Oh, hi.
Hi.
I don't know.
Are you, sorry, it just looked like you were wrapping up. I wanted to check in.
I am. Yeah, my iPad just went crazy.
Oh gosh, I'm
So-
sorry.
No, that's okay. I turned it off and I'm trying to get it back on here.
Okay. Yeah, I was just checking in with you. Sorry about that.
Ah, there we go. I think it's working again. Is it back on the screen now?
Yes.
Okay, good. There we go. Sorry, I have no idea what happened there. But so the distance around a circle is pi times the diameter. And arc length, an arc is just a part of the circle. So if I have like if I have an angle here and I just want to know what this distance is, I can find that arc length real quickly if I know what this angle is. If this central angle is like 70 degrees, I can find this by just making a simple ratio. The whole circle, pi, oh, I need to know what the diameter is too. Let's say the diameter of this circle is 12. So the whole circle is pi times 12. The little piece that I want, I'll call that x. All the way around a circle is 360 degrees. The angle for the piece that I want is 70. Okay, so I made a proportion here. The whole circle over the piece that I want. The whole circle, 360 degrees, over the degrees of the little piece that I want. When you have a proportion, there's a quick, easy way to solve it. It's called the cross products. You multiply this times this, and you multiply this times this. So 360 times x, that's what I'm trying to find, equals pi times 12 times 70. Well, now it's calculator time. So I'm going to go to my calculator and do pi times 12 times 70. So I'm going to go pi. I've got a pi key, but you can use 3.14 if you want. Pi times 12 times 70 That's ooh, big. 2638.9. 2638.9. And 360 times x. And now, just like a few minutes ago when we're solving an equation, to get the x alone, I have to divide by 360. So I'm going to divide this side by 360. So 26389 divided by 360 is approximately 7.33. Okay, so when you want to find arc length, you're going to make a proportion. It's the whole circle, pi times diameter, over the piece that you want, the arc that you want. And then you do the other part of the proportion is the degrees. The whole circle, 360 degrees, over the degrees of the arc.
Got it.
Does that help a little?
Yes, helped a lot.
Good, good. Okay, anybody else have some questions? Yeah, I apologize about my iPad. I don't know what the heck happened there. Something weird went. It's never done that before. And the camera wouldn't take a picture of the papers. Okay, well, anybody else? We got a couple more minutes left in this hour. So if you're any more questions, we can go over them.
Thank you very much.
Oh, you are very welcome. Anybody else? Any last questions? We can do the algebra or geometry or whichever math you're in. I think you guys are all in geometry and algebra, right? Okay, well, I'm about to wrap it up then if nobody else has any questions. If you come across something, you can email me or you can text me. You can text me there too. Oops, is that on there? What the heck?